Hello friends, welcome to another session of the respiratory physiology. Now we are seeing about the ventilation. Ventilation means what? The air from the atmosphere, it will go inside the lungs, it will reach up to the alveoli. And now we will be seeing about the exchange of the gases. That means the CO2 and the O2 is being exchanged from the alveolar air and into the capillaries, surrounding capillaries, mainly the blood which is coming from the pulmonary arteries. And the capillary goes to the capillaries and the exchange of the gases taking place. So this lecture is about the gas exchange. Now the main mechanism of the gas exchange or the transport is through the alveolo-capillary membrane is through mainly the diffusion. So diffusion is the process by which the exchange of the gases will take place. Now for that, what is the meaning of that? The oxygen, it will move from its higher concentration to the lower concentration. Similarly, CO2 will also move from its higher concentration to the lower concentration. Not only that, but you have to again remember that during, let's say, this was the position of the alveoli and the respiratory passage at the end of the expiration. What will happen when the person inspire? When the person inspire, the respiratory passage as well as the alveoli, it will get enlarged. It's because of the negative pressure in the rib cage. Once this gets enlarged, the suction effect will be created. Because of that, what will happen? The old air, that means which was the air already present, it will go inside and it will get more concentrated. And on and about that, the fresh air also which comes from the atmosphere, that will also be there. Now actually the exchange is taking place between the two. The continuous gases exchange is taking place between the alveolo-capillary membrane as well as there is the exchange of gases between the old air as well as the new air. What is the function of the ventilation? To keep the alveolar air concentration constant, mainly of the CO2 and the O2, so that the constant O2 supply and the CO2 that can be diffused out from mainly the pulmonary capillary, right? Now for that, you have to understand if you want to understand the diffusion of each CO2, O2, what I have told you, the CO2 will move from its higher concentration to the lower concentration. What will determine the concentration or the pressure of the CO2? What will determine the partial pressure? We will call that as a partial pressure now. What will determine the partial pressure of the O2? The atmospheric air is composed of number of gases. It is composed of CO2, O2, nitrogen. These are the major constituents and other small gases. Now, what is the definition of the pressure? Suppose in a box there is some air. Now, how much pressure it will create it? According to the definition of pressure, the number of molecules, air molecules, bombarding over the lateral wall on a unit area in a unit time, that is equal to the pressure. So if you can analyze that, more amount of the air molecules or more number of the air molecules, more will be the pressure, right? If you decrease the number of the air molecules, less will be the pressure. Not only that, but if suppose that is a mixed air, consisting of suppose A molecules and the B molecules, and if the number of A molecules are more compared to that of the B molecules, then what will happen to the number of molecules bombarding over the surface area? If the chances of A molecules bombarding over the surface area, that will be more. In that case, what we will tell that the partial pressure of the A is more than that of B. And what will be the total pressure of the air? That in that box, it will be the partial pressure of A plus partial pressure of B. That will be equal to the total pressure of the air. So what is in short, what you have understood? That the total pressure is summation of the partial pressure. We will call it as a partial pressure. And partial pressure in turn will determine by what? Number of those molecules, particular gas, or the concentration of that gas molecules or the concentration. So that will ultimately determine the partial pressure. So if you want to look at in the atmospheric air, just look at this now slide. How much is the normal atmospheric pressure? That is 760 mm of Hg. And now this will be comprised total of 593 mm of Hg. That will be the partial pressure of nitrogen, because of that is because the concentration of nitrogen is maximum. Then the 21% of that is equal to 160 mm of Hg. That will be the partial pressure of the oxygen and 7% will be the partial pressure of the other gases, which includes even the carbon dioxide, which is having the minimal list. So this much you understood. So whatever the air we inhale, the O2 partial pressure of O2, the partial pressure of CO2 will be determined by its concentration in that gas. Next important thing you should remember that whenever we inhale the air is getting humidified. Now what is the meaning of that? The water vapor which is very less outside, then the vaporization is taking place. The water is continuously being evaporated from the respiratory passage and the air is getting humidified, or water vapor is being added. When the inspiration will stop? The inspiration will stop when the air will, the pressure inside the alveoli will become equal to that of the atmospheric pressure. But now here we should also take into consideration that some humidification, some water vapor pressure is being also added. Its value is 47 mm of Hg. So in that case what will happen? The value of partial pressure of other gases will slightly decrease. So that because the summation should be equal to 760 mm of Hg. So what you understood that the partial pressure of oxygen will not remain same as that of the air, atmospheric air. But once it goes into the alveoli, the partial pressure of oxygen will slightly decrease. The partial pressure of carbon dioxide also will slightly decrease if it is going to the alveoli. But as we will see that the carbon dioxide is continuously being added into the alveoli. So the partial pressure of carbon dioxide will increase. So what you have to remember is that when we consider about the air which is there in the atmosphere, and when the air is going into the respiratory tract, it's getting humidified. Because of that, some percentage of that partial pressure is mainly taken up by the water vapor. So it will cause the changes in the vapor pressure. Not only that, as I have told you, the old layer which is there here, and the exchange is also taking place between the old layer and the new air. So the partial pressure of the alveolar air will be different than that from this dead space air. So that also should be taken into consideration, right? So the alveolar air concentration, that will be different, and whenever we expire now, there is a mixture of this alveolar air as well as this new air. So the expired air concentration will depend upon the diffusion which is taking place between the old air and the new air. So that will again determine the diffusion, right? Next, we have spoken about the partial pressure when it is in the air. But what about when the gases are dissolved in the fluid? Such as when we speak about the capillary here. So the gases are dissolved in the blood. So if the gases are dissolved in the fluid, what determines the partial pressure? The partial pressure in that case is inversely proportional to the solubility of the gas in that fluid. That means what will happen if the CO2 is, let's say, more soluble. In that case what will happen? The partial pressure of CO2 will be less compared to that of O2 which is less soluble. So partial pressure of the gas in the fluid will be inversely proportional to the solubility, right? And the net, so there is some partial pressure of O2, there is some partial pressure of CO2 here, there is some partial pressure of O2 and CO2 here. The net direction of the diffusion will determine by where the pressure is higher and where the pressure is lower, partial pressure. The moment will always be there from the higher pressure to the lower pressure, right? In case of O2, it will be from the alveoli to the pulmonary capillary blood, and whereas for CO2, it will be there from the pulmonary capillary blood into the alveoli. Now look at the partial pressure which is there in this table. As you can see, the partial pressure of which we are mainly interested is the O2. How much is the partial pressure of O2 in the atmospheric air? 159 mm of Hg, because the percentage is 21%, right? But when it is getting humidified air, 47 mm of Hg, that is the humidification that is being added here. Look at the humidification here, it is added. In atmospheric air, the water vapor pressure was just 3.7 mm of Hg. But now it has become 47 mm of Hg. So what will happen? The partial pressure of the oxygen will decrease and it will reach to 149 mm of Hg, right? But when it goes to the alveoli now, actually the alveolar air partial pressure of oxygen will be 104 mm of Hg. Remember, 149 mm of Hg, this is the partial pressure which will be here, that is the new air. And in the alveoli, there is continuous exchange is also taking place. So at the alveoli, the partial pressure will be 104 mm of Hg, right? But whenever the person is expiring now, so it will contain a mixture of this new air as well as the alveolar air. So that expired air will have the partial pressure is equal to 120 mm of Hg, right? So, but what we are mainly interested is now the partial pressure of the oxygen in the alveolar air. How much it is? 104 mm of Hg. And look at the partial pressure of oxygen in pulmonary arterial blood, which is the blood which is coming from here. How much is the partial pressure of oxygen in the pulmonary arterial blood? It is 60 mm of Hg. And how much is the partial pressure of oxygen in the alveolar air? 104 mm of Hg. So now, if this blood is reaching at this point and the exchange has started, naturally oxygen will move from alveoli to the blood. And whenever this blood is exiting the pulmonary capillary, at that time the partial pressure of oxygen will be equal to that of the partial pressure of oxygen in the alveoli. That means it will become 104 mm of Hg, right? Now next we will look for the partial pressure of the carbon dioxide. How much is the partial pressure of carbon dioxide in the atmospheric air? 0.3 mm of Hg, right? How much is the partial pressure of the carbon dioxide in the humidified air? It will just decrease slightly. We can say that it will just remain 0.3%. But in the alveolar air, since rapidly this carbon dioxide from the blood is giving out into this alveoli, the partial pressure of the carbon dioxide in the alveoli, it will be 40 mm of Hg, right? Now look at this figure. How much is the partial pressure of carbon dioxide in the pulmonary arterial blood? It will be 46 mm of Hg. How much is the partial? So whenever the blood is flowing in this direction, now this carbon dioxide will be given up. And how much will be the partial pressure of carbon dioxide in the alveolar air? It is 40 mm of Hg. So up till this balance is reached, now carbon dioxide is continuously being evolved into the alveoli. And whenever this blood is exiting the pulmonary capillary, now the partial pressure of carbon dioxide will be equal to 40 mm of Hg. That means it is equal to the pulmonary, that is alveolar partial pressure of carbon dioxide. That will be equal to that, right? So one important thing again you have to note down is that the systemic arterial blood, comparatively, actually how much it should have the partial pressure of oxygen, that should be equal to 104 mm of Hg. That should be the same. But since there is a mixing of the venous blood, deoxygenated blood, bronchial vessels, thus there is some mixing of the blood from the bronchial vessels, so deoxygenated blood is mixed, so therefore the partial pressure of the blood, systemic arterial blood circulation, that is equal to the 95 mm of Hg instead of the 104 mm of Hg, right? But again you have to understand in this table is that the total pressure is always equal to 760 mm of Hg, right? So that's equal to, this is the concept of the partial pressure. Now coming to exactly the site where the diffusion is taking place. The diffusion is taking place at the alveolo-capillary membrane. So what are the layers of this alveolo-capillary membrane? We will start it from inside. So what will be the innermost layer? That means a fluid. As I have told you, the alveoli are lined by fluid. So water will be lying there, and that fluid will be having surfactant also in this. So a layer of fluid along with the surfactant that will be lying in the alveoli. Next, the alveolar epithelial, thin epithelial cells, which are having the more diffusing capacity. So this thin alveolar cells that will be lining. Next, then the outer will you have the basement membrane layer for this epithelial cells. Then you will have a thin interstitial space. We can call it as the interstitial space. Then what you will have is this is now the capillary. So outermost will be the basement membrane of the capillary endothelial cells, and then innermost will be the capillary endothelial cell layer. So what are the layers from outside to inside? A layer of the fluid along with the surfactant. Then you have got is the thin, that is alveolar epithelial cells, then the basement membrane of those alveolar epithelial cells, interstitium, then you have got is the basement membrane of the capillary endothelial cells, and then you have got is the capillary endothelial cells. Remember that CO2 and O2 has to pass across all these layers. If at all there is the thickness, mainly the thickness of this layer is increased, in that case what it is going to do? It is going to affect the diffusion. Diffusion, as you know that, what are the factors on which the diffusion depends upon? The diffusion will depend upon, just be with me, it is proportional to. Diffusion is proportional to what? It is directly proportional to the pressure change. Pressure change means what? If there is a more pressure difference, more will be the diffusion, right? So it will be directly proportional to the delta P or the pressure change. Next, if there is a more diffusion area if it is increased, again it is going to increase the diffusion. Next, if a gas is more soluble, such as carbon dioxide, it is more soluble. So the solubility will cause easy diffusion. So that means diffusion is again directly proportional to what? Solubility. Right? Next, diffusion is inversely proportional to what? Diffusion is inversely proportional to the thickness of the membrane. If the alveolo-capillary membrane becomes more thick, the gas will have more difficulty for the diffusion. So it is inversely proportional to the thickness. Next, if the molecular weight of the gas is more, which is being taken into consideration, so naturally the diffusion will be less. So it is again inversely proportional to the square root of the molecular weight. Now if you analyze this equation, the pressure change, that is always there, the area which is there, this factor, mainly the solubility and the molecular weight, this is the factor which is mainly much more related to the gas as such, the property of the gas as such. This is called as the diffusion coefficient of the gas. So what is diffusion coefficient of the gas? Solubility divided by the molecular weight, right? The diffusion coefficient for carbon dioxide is about 20 times more than that of the oxygen, because the carbon dioxide is more soluble as such. So that's why that is. When it comes to the other factors which are going to affect the diffusion, the thickness, as I told you, is very, very important. The thickness of the alveolo-capillary membrane can increase in some conditions. Fibrosis, it can even increase in case of the pulmonary edema. So in this case, the diffusion will be significantly affected. When it comes to the area, how much is the area for the diffusion? If there is that is the pneumonia. So pneumonia will cause what? The infiltration of the alveolar membrane, and ultimately it will decrease the surface area for the diffusion. So in that case, the diffusion that will be decreased, right? Diffusion is also affected by the V by Q ratio. This also you should remember, that the ventilation perfusion ratio is also going to cause the diffusion. If the ventilation perfusion ratio is more than ideal, then the dead space will be created, some air will be wasted. If the ventilation perfusion ratio is less than ideal, there will be some excess perfusion, and that deoxygenated blood will mix with the oxygenated blood, and ultimately a shunt will be created, right? Normally, the diffusion is almost complete. You just look at this picture. This is the pulmonary artery capillary, and this is the blood which is coming, deoxygenated blood, and the diffusion has completed even before half of this has crossed, that the blood has gone. Nearly if when the blood moves about 1/3 distance of the capillary, the diffusion is almost complete, and the blood here will be in equilibrium. Equilibrium is what I am going to say is that the partial pressure of oxygen and the partial pressure of carbon dioxide will be equal to that of the partial pressure in the alveoli. So the blood will be there in the equilibrium. This will act as a safety factor, because sometimes if the more oxygenation is required, or if the velocity of the blood flow has increased, in that case also the diffusion is ensured that the diffusion may not take place at 1/3 of the length, but it will take at half of the length. But that is again a safety factor that is much more important in that. Not only that, but the diffusing capacity is much more increased during exercise also. What will happen during exercise? The more number, that is because of the better ventilation perfusion ratio, you can say that. what will happen? The pressure, even the pulmonary arterial pressure, that will be more increased. In that case, what will happen? More perfusion that will be there. At the same time, ventilation is also increased. So the ventilation perfusion ratio is better reached, especially in the upper lobes. Because of the more pressure now, the perfusion is increased in the upper lobes, and the more amount of the oxygen that can be absorbed from the upper lobes also. So this will happen especially during the exercise, right? So with this, we come to the end of this lecture. Thank you.